Good morning. Now, today we will start our first class on your fourth semester. The name of the paper for your fourth sem is Optics and Solid State Physics. So, that paper has got 4 units. So, in that, I will be teaching you the fourth unit, which is named as Crystallography. And after completing this unit, I'll be teaching a few portions either from unit 1, 2, or 3. Okay, so first of all, let us begin our unit 4, that is crystallography. Okay, now what is crystallography or what is solid state physics? It is nothing but a branch of physics that deals with the physical properties of solids, as the name indicates, especially crystals, including the behavior of electrons in these solids. So, crystallography or solid state physics is nothing but a branch of physics that deals with the study of crystals as well as on the behavior of electrons in these crystals. As you all know, solids are broadly classified into two. This you might have studied in your lower classes. That is crystalline and non-crystalline. That's a broad classification. Non-crystalline solids are also called by the name amorphous. That is the spelling, hope you know, amorphous. Okay. This is another name for non-crystalline solids. Okay. So, solids are broadly classified into two, that is crystalline and non-crystalline. Non-crystalline are also called by the name amorphous. Now, can you define what are crystalline solids? In crystalline solids, there is a regular or periodic arrangement of atoms or molecules. Okay, that is, there will be a long range periodicity. That is, they are of long range order. That is, wherever you go, you will see a periodic arrangement of atoms or molecules. But just the opposite will be the case of non-crystalline or amorphous solids. That is, there will not be any regular or periodic arrangement of atoms or molecules. That is, periodicity will be of short range order. That is, there will not be a uniform pattern in the arrangement of atoms or molecules as we go inside the as we observe the structure inside the solid. Okay, now this uh, this one crystalline state is a low energy state because it is a most stable state, and energy released during the formation of an ordered state is more than the energy released during the formation of a disordered state. So a crystalline state is a low energy state, and hence it is highly stable when compared with non-crystalline state. Now this crystalline solids are again classified into two, that is single crystals and polycrystalline. Now, definition for single crystal means they have a regular or periodic arrangement of atoms or molecules, and the periodicity extends throughout the cell. That is, they exhibit long range periodicity. And some examples for single crystals are diamond, quartz, mica. Now, another category that belongs to the crystalline solids is called by the name polycrystalline. Okay, polycrystalline means it is nothing but an aggregate. Aggregate means a collection of a number of small crystallites, or that crystallites are also called by the name grains, grains. Okay, so it is nothing but an aggregate or collection of a number of small crystallites called grains. Uh, with the random orientations. That is, these grains will be orienting in different directions, and they are separated by well defined boundaries called grain boundaries. So polycrystalline material means a collection or aggregate of a number of small crystallites called grains having random orientations and separated from each other by grain boundaries. So in these polycrystalline materials, this periodicity is disturbed at grain boundaries. That is, you will not see any periodic arrangement of atoms or molecules at the grain boundaries. That is, periodicity is disrupted or destroyed at grain boundaries. Okay, some examples for polycrystalline materials are metals and ceramics. However, these polycrystalline materials are more stable compared with single crystals. Okay, So the last one is the other classification, that is non-crystalline or amorphous. What was the definition that I told? That is there you cannot see, or there will not be any regular or periodic arrangement of atoms or molecules. That is they are of short range periodicity. That is periodicity do not extend throughout the cell. That is periodicity extends only up to a distance of few atomic diameters. And examples are glass, plastic, rubber, etc. Okay, so this is a very important session. That is a sure question. That is how solids are classified and give examples. So solids are broadly classified into two, that is crystalline and non-crystalline. Non-crystalline means amorphous. Then this crystalline are again divided into two, which are the single crystals and polycrystalline materials. Then you have to define, or you have to explain their peculiarities along with examples. So that's a sure question. Now we will see what is a crystal structure. Actually, a crystal structure is composed of two factors, that is lattice plus basis forms the crystal structure. Lattice plus basis, they together form the crystal structure. So the arrangement of atoms in a crystal is called crystal structure. Now an arrangement of infinite number of imaginary points having identical surroundings is known as lattice. So both the definitions you can see here. And the arrangement of atoms in a crystal is called crystal structure. Now an arrangement of infinite number of imaginary points having identical surroundings is known as a space lattice, just like that shown here. That is you can have some dots, that is a regular arrangement of infinite number of imaginary points having identical surroundings. This is called a lattice. So a two-dimensional lattice is shown here. So in this lattice they have taken an arbitrary origin O. From that origin they have drawn two position vectors. One is R1 and the other is R2. Now the difference between these two position vectors is represented by a capital letter T, and it is given by n1a vector plus n2b vector, where n1 and n2 are integers and vector a and b are called fundamental translation vectors. Now if you are considering a three-dimensional lattice, then an additional one more term will come. See this one. This are only two terms, so it is denotes a two-dimensional lattice. Here there is an additional term, so this actually represents a three-dimensional lattice. All the terms have the meaning that I have already explained. n1, n2, n3 are integers, whereas a, b, c vectors are called fundamental translation vectors. Now there is a definition for crystal lattice. It is that is another definition. That is, it is actually refers to the geometry of a set of points in space, whereas a crystal structure refers to ordering of ions, atoms or molecules in space. Okay, so here from here you have got the definitions for crystal structure. Then lattice plus basis forms a crystal structure. Then you got the definition for a lattice. Then you got the definition for a translation vector. Okay, now the only thing that you need is a definition for a basis. Let us see what basis is. See, lattice plus basis equal to crystal structure, what I have told. Here we have already discussed about the definitions for crystal structure and lattice. Now we will have to see about basis. Now I already told you that a regular arrangement of infinite number of imaginary points in three-dimensional space having identical surroundings will form a lattice, as shown like this. Now when you associate with each of these lattice points, if you associate an atom or molecule, then this will form a basis. Okay, that is, for each lattice point, if you associate an atom or molecule, okay, this is a lattice point, it is associated with an atom or molecule. Another lattice point associated with an atom or molecule. Then once each and every lattice point is associated with an atom or molecule, then you will get a basis. Okay, and When this basis is repeated periodically in a regular fashion in all directions, then you will get the crystal structure. Okay, so lattice plus basis form the crystal structure. Structure of a crystal is the crystal structure. What is lattice? A set of imaginary points in three-dimensional space having identical surroundings. When you associate with each of these lattice points an atom or molecule, then you will get a basis. When this basis is repeated in a regular fashion in all directions, you will get the final crystal structure. Okay, see, this is a basis. You are associating with each lattice point an atom or molecule, just similar to the figure that I have drawn just now. If the basis has got only one atom, then you call it as a monatomic. Examples are copper and sodium. If it has got two atoms, it is diatomic. Example, sodium chloride, cesium chloride. If the base is associated with three atoms, then it is triatomic. Example, calcium fluoride. Next one is the definition for unit cell. Okay. A unit cell is actually the basic or the fundamental building block of a crystal structure. Or another definition is that it is the smallest volume cell which, when arranged in three dimensions in a regular fashion, generates the entire crystal structure. So you can study any of these two definitions. What is it? Unit cell is the fundamental or the basic building block of a crystal, or it is the smallest volume cell which, when arranged in three dimensions in a regular fashion, generates the entire crystal structure. Now, in order to define or in order to describe a unit cell, you need to use certain vectors, that is vector A, vector B, vector C. They are actually called lattice vectors. Now the angle between these lattice vectors A, B and C are denoted by alpha, beta and gamma, and they are called interfacial angles. So in order to describe a unit cell completely, you need lattice vectors, vector A, vector B, vector C, as well as angle between those lattice vectors named as interfacial angles, namely alpha, beta and gamma. So these lattice vectors and the interfacial angles together is called by the name lattice parameters. So in order to describe a unit cell completely, you need lattice parameters. That is, you must have a knowledge about lattice parameters. Next is primitive cell. A unit cell that contains one lattice point only at corners is called primitive cell. Or it can also be defined in another way, that is, primitive cell is the smallest volume cell having only one lattice point per cell. Okay, smallest volume cell having only one lattice point per cell. Whereas non-primitive cell means smallest volume cell having more than one lattice point per cell. Okay. So from today's session, you have come across a few definitions, that is, distinguish between crystalline and non-crystalline materials, that is a classification of solids with examples, then unit cell, primitive cell, non-primitive cell, define crystal structure, define lattice, define basis, define translation vectors, define lattice parameters, etc. So please read through this and study all these definitions. Okay, now along with this I will upload the complete notes on this chapter crystallography. and on each week I will take small small portions from that notes that is already uploaded. Okay, I will please read through today's portions. So today this is enough. Thank you.